You're outside on a stormy day, waiting for that iconic crack of thunder and flash of lightning. But what if those strikes just stopped, or rather dwindled to a mere whisper? One lonely bolt every hour, zapping down in some random corner of the globe. No more dazzling light shows during storms, no more heart-pounding booms that light up the night. Welcome to our latest What If adventure. What if lightning struck every hour in random places on Earth? This isn't just a fun thought experiment. It's a dive into how one tiny tweak in nature could unravel our world in ways you never imagined. Right now, Earth is a lightning hotspot. It experiences millions of strikes every single day happening non-stop. That's like nature's own fireworks display going around the clock. Most strikes hit the tropics where heat and moisture brew perfect thunderstorm conditions. But in our hypothetical, everything changes. Lightning becomes incredibly scarce. Only 24 strikes a day, each in a totally unpredictable spot. Maybe over the ocean, a desert, or even your backyard, but rarely. Why does this matter? Lightning isn't just dramatic, it's a powerhouse player in Earth's systems. It zaps the air with massive energy, hot enough to rival the sun's surface. That energy splits nitrogen molecules, the stuff making up most of our atmosphere, and turns them into compounds that fertilize the soil like a natural boost for plants. Without it, crops could struggle. Lightning also helps produce chemicals that clean the atmosphere and keep air quality in balance, and it maintains the planet's overall electric field, balancing charges between the ground and the upper atmosphere. In this world, the immediate shock safety skyrockets. Lightning causes thousands of deaths and injuries every year worldwide. With strikes rarer than ever, outdoor sports, hiking, and even daily life become much safer. Power companies benefit too. No more surges damaging equipment or causing blackouts. Wildfires started by lightning would drop dramatically, meaning less destruction in forests. But hang on, that's a double-edged sword. As we peel back the layers, you'll see how this rarity ripples into bigger changes. Soils could turn less fertile, ecosystems might shift, and the atmosphere could behave differently. Stick around, things are about to get surprisingly weird. But first, let's break down the science behind the spark. Scientific background. Let's geek out on lightning basics. Thunderstorms form when warm, moist air rises, cools, and condenses into clouds. Inside, ice crystals and water droplets collide, separating electric charges, positive up top, negative at the bottom. When the difference builds up enough, boom, lightning discharges, equalizing it all. This isn't random, it's pure physics in action. The intense heat from a bolt expands the air explosively, creating thunder. But beyond the spectacle, lightning acts like a chemical factory. It breaks apart tough nitrogen molecules, forming compounds called nitrogen oxides. These get washed into the soil by rain as nitrates, feeding plants and microbes. Globally, lightning provides a significant amount of natural nitrogen fertilizer each year, a key part of how Earth stays green and productive. Then there's its role in the atmosphere. Lightning's energy creates ozone and other molecules that help clean pollutants from the air. In the lower atmosphere, this influences air quality in complex ways. And don't forget the global electric circuit. Earth acts like a giant battery, with the upper atmosphere positively charged and the ground negatively charged. Lightning constantly rebalances this system, keeping a steady voltage difference. In reality, reducing lightning so drastically would require overriding natural atmospheric physics, which is impossible under normal conditions. But that's what makes this what if so fascinating. Imagining the fallout from such an extreme, tiny change. Cliffhanger. What causes this sudden rarity? A mysterious event or unexplained shift? Next, the moment where everything changes. The shift happens overnight. Imagine a massive, unexplained event blankets Earth, altering how clouds build electric charges. Charge separation in storms weakens dramatically. Instead of thousands of strikes per storm, maybe just one, or none at all. Globally, lightning drops to 1 strike per hour, completely randomized. Why random places? In our scenario, any leftover charges discharge wherever they find the easiest path. Ocean, mountain, city, anywhere. No more predictable hotspots in certain regions. This small change? It's like removing a key piece from a complex machine. Storms still bring rain and wind, but without the electric drama. The immediate feel. Storms become eerily quiet, no bright flashes, just distant rumbling, if anything. People notice fast. Weather experts scramble as storms appear but produce no lightning. Headlines explode with the news. Social media fills with questions and theories. But the real shift is hidden at first. Natural nitrogen input to soils drops almost completely. Chemical production in the atmosphere slows. Electric field monitors detect strange imbalances. Could this lead to bigger issues like more radiation reaching the surface? It's speculative but possible. Hang tight. The immediate effects are coming next. Day 1. The world experiences storms without sparks. A big thunderstorm passes through. No flashes, just wind and rain. People in storm-prone areas feel confused at first. Outdoor activities continue without the usual warnings. Safety improves instantly. Lightning-related deaths, injuries, and damage to animals or property become extremely rare. Insurance costs drop. Power grids stay more stable without sudden surges. Fires. In dry areas, fewer lightning-started wildfires mean less immediate destruction. Forests and wildlands see reduced burning, leading to less smoke in the air during summer seasons. Atmosphere-wise, production of certain cleaning compounds drops quickly. In some polluted areas, air might feel clearer at first, but in cleaner regions, natural processes slow down. Electric balance. Without regular discharges, the planet's overall charge starts to shift unevenly. This could cause minor oddities, like more static electricity or unusual weather patterns emerging. Ecosystems. Wild plants in remote areas begin to feel the nitrogen shortage early. Growth slows slightly. Decomposition processes change. Society adapts quickly at first. Scientists rush to study the phenomenon and explore ways to create artificial solutions. But as time passes, deeper effects start to show. Cliffhanger ahead. Years later, Earth's landscapes change subtly. The massive loss of natural nitrogen fixation hits agriculture over time. Crop yields could drop without extra help. Food production needs more human-made fertilizers, raising costs and environmental concerns. Ecosystems evolve. Areas that rely on periodic fires for renewal become overgrown. Certain plants and animals that depend on fire struggle, while others thrive in denser habitats. Biodiversity shifts in unexpected ways. Atmosphere. Reduced chemical reactions mean slower natural cleaning. Air quality changes regionally. Some places benefit, others see buildup of certain gases. Weather patterns might adjust as a result. Global electric circuit. Without constant rebalancing, the system weakens over time. This could allow more solar particles to reach the surface, potentially affecting technology or health in small ways. Humanity responds with innovation. Engineers develop large-scale systems to mimic lightning's benefits, like producing nitrogen artificially on a bigger scale. Society might shift toward more controlled environments, appreciating the rare natural strikes when they happen. But in extreme cases, if the nitrogen loss isn't managed well, food shortages could emerge in vulnerable regions. On the positive side, safer outdoor life, fewer fire disasters, and perhaps cleaner air in some ways. Branching scenarios, alternatives. Branch 1. Strikes limited mostly to oceans. Land stays mostly unaffected. Nitrogen impacts hit marine life more, possibly boosting certain ocean ecosystems while sparing farms and forests. Branch 2. Random strikes occasionally hit populated areas. Though rare, each one causes major disruption, power outages, or damage. People might develop new safety habits or technologies to predict the unpredictable. Compare. In a world with way more lightning, constant storms would bring floods and fires but ultra-fertile soils. Our scenario offers calm on the surface, but hidden slow changes versus that one's obvious dangers. What if the rarity affected only certain hemispheres? Migration patterns or farming could shift dramatically. Which version sounds more challenging to live in? Wrapping up. A world where lightning strikes only once an hour? It starts safer and quieter, but over time brings challenges from reduced soil fertility, overgrown ecosystems, and atmospheric shifts. Earth's balance is more fragile than we think. Key takeaway: lightning does far more than light up the sky. It's essential for fertility, air quality, and planetary electricity. This what if highlights how interconnected everything is. What do you think? Would you miss dramatic thunderstorms or enjoy the peace? Comment below with your thoughts. I'd adapt by hit like if this sparked new ideas for you, and subscribe so you don't miss more mind-bending scenarios.